Assalamualaikum warahmatullahi wabarakatuh. So here I'm from computer graphic course, group 5. I'm Putra Sultansyah, NRP 5025 0221098. So here me and my group will present our final project. So basically what we try to recreate here, we are trying to recreate the prayer room in the informatic departments. So as you can see here, we are decided to use 3GS and React. So here we use a style of old graphic. Okay, so now I will show our project setup. As you can see here, because we are using React. So in here, the setup is quite typical of the latest React app. So for the main, this is the main. The first one is the main. This is will be our render inside. Is it for the layout? It's supposed to for layout for normal main for normal React app. So then our function is primarily get run from this from the app.js. As you can see, we are using different function also inside this library to host the post processing and also the scene and animation initialization inside for the project. So as you can see, the reason why we make a separate function because we want to decrease the I said yeah, to decrease the line amount. So basically in here we can save around like 100 line. So the rest will be processed inside this. For this is for the scene. So we use the separation is basically for fundamental component that won't have much change later, such as the ambient light, direct light, camera control, and etc. And then next our is the public folder. Here we use it to save our finished model and also to and now I will show the scene setup, the initial scene setup. Like I said previously, I use different function. I put it in different function inside the library folder. Here in the scene init.js. As you can see here, this is where we initialize our scene. So first of all, this is the constructor. So it's basically just constructor to input the variable and etc. And here the first function is initialize. And as you can see here, first we have the screen resolution setup. The reason we have this screen resolution setup so that we to make sure that because our post processing is basically try to recreate an old graphic, old pixelated graphic so that we try to also modify the screen resolution. And then next, this is our scene initialization. So basic add new skin and etc. And then next, this is our yeah, the render setup here. This normal render setup where we will later put our rendering inside web the React web app. And then next is our post processing setup. Here, this is where we are calling our post processing function. As you see here, our all of our post processing function is saved inside the library folder. Next, I will show you our models. Here, so basically, we have two models that was imported for the project. So as you can see, first here, we have the prayers room. This prayers room is basically taken from our department's prayers room. As you can see here, we use a software called Blockbench. So basically, this is a modeling software for a low poly style graphic. So if you want to create something that basic or looking kind of old style graphic with lower polygon amount, you can use this software. So, okay, okay, this is our first model, and then our second model is a bus, just for the interactivity. In this model, we also have animation. Here, as you can see, our animation will be played for the interactivity. Here's our animation. It's basically just the bus bopping around. Yeah, just bopping like to highlight that you press the bus like this. So this is where we import our model. So we like I stated previously that this is only for this AppGSX is only for the component that need to be changed so much, such as the model. So okay, first of all, for model, we use the LTF loader because our model is exported in the LTF format. Here, our first model, Busola, which is per room. Previously, we put our model inside the public folder here. And for the model setup, we only rotate it in 180 degrees in Y axis. And then we also add it into the scene. This is the scene initialization previously was called. And then for second model is this one, the bus, same format as the prayer room previously. And here we also add animation mixer because this model has animation. So for our transformation and translation or rotation, we only add translation and scale. Here we scale it twice around X, Y, and Z axis. And then for position, we position it around X and Z because we don't need to change the Y. And for rotation, we also have rotation in the Y to make it better. Yeah, and then this is the animation we are using Mixer to get the animation inside the GLTF folder. The LTF file. Okay, then we will show you our camera setup. So okay, first this is our camera. Here, as you can see, the camera is a perspective camera, and and our this is our camera position. Again, then next for our camera control, here we are using orbit control because we just want to show the model. I need to show the model like around and rotate, so we just use the orbit camera, orbit control. And in order to make the orbit control, we also use the clock function to make the orbit camera and also the animation here. And then the rest just the start. So the camera is only for this one. So the reason we put our camera setup inside the separate file because this file is for the least edited component for our project. So we put it in here because this is quite simple.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fawwaz Jawi. and I'm going to explain a little about this. First, we use an ambient light. The ambient light is used to light up the entire scene. It's not a specific direction or a specific object, but the entire scene. So it is static ambient light that tries to uh, scale up the contrast of the entire scene. We set this value into a white light in the intensity of 1.5. Uh, Next, we also use directional light. This directional light is used to create a shadow and also a simple contrast with the object, make the object uh, more sporadically divided on the lighting. As you can see here, this is divided with the light hit by the directional light, and this is the part that is cast by the shadow. So this part is a bit darker, and this part is a bit lighter. Here is the same because this both part is hit by the light. Okay, the directional light. We use gray, a gray light, so it's not really intense color, and also the intensity of 0.5, so it's not very intense. And of course, we use the cache shadow value set to true, and the position is set far away from the seed, so it is pretty far in the scene, so that it does not really affect all, but it's subtly affect uh, affect the parts of the object at the bottom. Next, we also add a simple spotlight to add variation to the light in the scene. So for the spotlight is pretty full. In the middle is the spotlight. We set the spotlight into position close to the scene, and color is a bit yellow with the intensity of 500, so it's pretty intense, and the range is 100, so it is very far. The angle, uh, the angle is pi over 16 radian, and also this is the decay rate, and I think this is the softness of the light. So the edges of the light to which it fades in or fades out. Okay, and this is the target which the spotlight is trying to, which is the center of this model, a bit, a bit shifted to the left, to the right, but uh, it's just trying to project into the center of this model, and it hits from the front, so it gets bit noticeable that this is the front part of the musala. That is all from the lighting aspect of the process, the model. Uh, I don't think it's more of the lighting, only ambient, directional, and also spotlight. Thank you very much.
Hello, my name is Joanes Bosco Bhramantyo. My NRP is 50 25 22 1111. Next, I will be explaining about the post-processing part of our project. In here, I will be explaining in the Pixelate Pass uh, JS. First, I'll be explaining about the component. In here, we have the Pixelate Pass class. In here, it is a basic component for the post-processing uh, pass in 3.js. And this Pixelate Pass, it is a specialized pass that will be applied after the scene is rendered to add the pixelation effect. And in here we have the constructor, and it accepts a resolution, and this resolution is used to determine the how much pixelation should be applied, and the resolution presents the number of pixels for the final rendered image. And this full screen quad it is used to render the full screen, and it passing the pixelated texture through the custom shader. It will be used. It will use the material generated uh, by the this material to render the screen. Next is the render method, and it is for applying the pixelation, and it is called a rendering loop, and to apply the pixelation effect, and it takes several parameters. Um, in this one, the renderer, it represents the WebGL renderer to render the write buffer and the read buffer. Uh, and this uniforms uh, diffuse value is a uniform connecting the texture from the read buffer and to the pixelation shader, and then it is passed to the T diffuse. The render target, this one, it determines where the rendered image is output. And if the render to screen is true, the image is rendered directly to the screen. And if it is not, it is rendered to the write buffer. And next is the material method. And this one is basically for defining the shader. And the this material method, it returns a new 3.shader material, and it is a custom material for your pixelation effect. And in here, as you can see, there are three properties, which are uniforms, vertex shader, and fragment shader. First, the uniforms is it holds the texture of the scene or the texture to be passed through the pixelation shader, and it is set to null initially, and it is assigned the texture from the read buffer in the render method. And then the resolution uniform defines the resolution used for pixelation and is represented as 3.vector4 in there. And the first two components, the resolution X and Y, uh, it specify the target resolutions, well, the height and the width, while the last two, this one, 1 over this representation X and Y, is used to calculate the pixel size in the shader. For the vertex shader, it executes for each vertex of the geometry being rendered. In the case of a full screen quad, the vertex shader is relatively straightforward. It passes the VUV to the fragment shader, which provides texture coordinates for each fragment, and the gel position is calculated by transforming the vertex position using the model view and projection matrices and determining the final screen position of the vertex. Lastly is the fragment shader, and it process each pixel of the rendered image to apply the pixelation effect. And the T-diffuse uniform represents the texture passed into the shader. And uh, when the scene texture or the output of the previous post-processing step, and then the resolution XY component specify the width and height of the target resolution for pixelation. And in here, it is multiplied by the VUV and the UV coordinates of the fragment to align the texture with the pixel grid. And the floor resolution XY, eh, using the UV coordinates are rounded to the nearest pixel grid. It creates blocks of pixels that produce the pixelation effect. And to center the pixels on the grid, the 0.5 is also added, and the result is scaled back to the correct range using resolution ZW, and the texture is then sampled at the adjusted UV coordinates. And then using the texture 2D, uh, it this one is for fetching the color of the pixel at the new coordinates, and this one is to set the fragment output color to the sample pixel. And that is all for the pixelation effect. And then next is for the mechanism. The main technique that makes the pixelation effect work is the floor function, which is applied to the texture coordinates. And by multiplying the UV coordinates by a resolution factor and flooring the result, the shader effectively rounds the UVs to the nearest grid point, and it's grouping the nearby fragments or the pixels together. For example, if you want a low resolution look, you might divide the screen into large blocks of pixels, and the shader will then sample the texture at the grid points and render the entire block of pixels with the same color, making the pixelated effect.
Hello, my name is Muhammad Azril Ananda, and here I will explain uh, our final project on part interactivity. So first is this on click on mouse click. So here, so this on mouse click even trigger when the user click left mouse or on an element. So it's directly in HTML using the onClick attribute. And here is the event client X and event client Y. Its properties provide the pixel coordinate of the mouse. Relative to the viewport, these coordinates are normalized to range min 1 to plus 1 to match 3JS coordinate system for ray casting. And then next is for our animation. So our animation will be on the bus here. The animation is on the bus. So when we click it, the bus will be animated like it will bigger or yeah bigger and then smaller again bigger. So when it's small, it reset the animation so that yeah it's for the next animation. So here bus. So when a model bus is loaded, it will contain animation stored in animation array. here's the array, and then the mixer this mixer method is used to create animation action object for the specific for the basic here. It will clip the anim. So and then the mixer of the animation mixer with the model, it handle playback of animation, and the anim specific client from the model. Usually first one will be KLVT0, scene animation 0, and for so configure we configuring the animation action. We set animation loop here. Why the you loop? So this is answer that the animation play only once and does not repeat. Yeah, there is other option include three loop or three loop ping pong, but we use only this three loop once, and then we reset the animation. So why we reset this animation? Because this reset, like I said before, the reset of the animation time to beginning. So it's ensuring it start from frame zero. This is important because if the animation was already play before, it might resume from where it stopped. And then we playing the animation. So action plays, start playing the animation. The mixer handles the actual playback in real time, syncing it with animation and tracks. It frame update. And then how we triggering the animation interaction. So the raycaster here, it detect mouse click on object. So if the object is interested with the mouse pointer, the animation action is triggered. So here for example, yes, here, the mouse interacting with the bus, it will uh yeah made the animation. So I think that's all our final project. This is the last uh step. Yeah, it's the last for the animation. Thank you.